Hello friends, this next question is from the test series 4 and from the subjects of network, and the topic name is network solution methodologies. In the problem we have one resistive network with a value of 3 ohm. In the parallel we have a load, one variable load, and across this load in the parallel of this load we have one more RL network. The load has unknown value ZL, and we have one 2 ohm resistor and one 10 ohm resistor. Okay. Now we have to, and there is one supply voltage of 50 volt with a phase angle of 45 degree. So we need to calculate. They have two questions, the link data question. The first problem is we need to find out the maximum value of ZL, the value of ZL such that maximum power should be transferred. The value of ZL for maximum power transfer. Maximum power transfer. And the second problem is we need to calculate the maximum power that can be transferred. That maximum power that can be transferred. In the first problem, we need to calculate the value of ZL for maximum power transfer, and the second problem we have to calculate that maximum power that we can transfer. So for the first part, for the value of ZL, what we do is a standard method. We find out the Thevenin equivalent resistance. So replace the ZL as an open circuit, replace this voltage source as a short circuit. So now my equivalent circuit will be this 3 ohm, which is short circuit, two ohm resistor, and a 2 ohm, and we need to find out that ZTH across these 2 points. Okay, so my ZTH will be this 3 ohm parallel with 2 plus J10, which is 2 plus J10 into 3 upon 3 plus 2 plus J10. So basically my ZS is equal to, by solving this equation, is 2.64 minus J 0.72 ohm. So for my first part, my ZTH is 2.64 minus J 0.72. For this part, the correct option is option C in your paper. So for the second part, we need to calculate the maximum power that can be transferred. So for the maximum power that can be transferred, we know that the P max is basically VTH whole square upon 4 RTH standard result. We already know RTH because in our case it is ZTH, because we have a reactive network. For the resistive network it is RTH, for reactive network it is ZTH. We already have ZTH. The only thing is unknown is VTH, or Thevenin equivalent voltage. We have calculated the Thevenin equivalent resistance across ZL. Now our next task is to calculate the Thevenin equivalent voltage across ZL. So now let's draw the equivalent circuit for Thevenin equivalent voltage. So this time we have a 3 ohm resistor followed by a 2 ohm resistor, then J10 ohm. For Thevenin equivalent voltage, we will also have a voltage source, supply voltage, which is 50 angle 45 degree. We need to find out the VTH across this terminal. So VTH across 2 ohm plus Z2 ohm will basically a voltage divider, because the voltage across 2 ohm and Z2 ohm, the voltage across these two networks is nothing but about my VTH. So if I may apply the voltage divider across this network, so I can simply find out the VTH. So my VTH will be equal to the 50 upon in 50 into 2 plus J10 upon total network, which is 2 plus 3 5 plus J10, which is 45.6 into angle of 60.26. This is my VTH. So I know the VTH. I already know the RTH. So I just calculate the VP max, which is 45.6 whole square upon 4 into 2.64. I'm just calculating the real values. So my P max will be equal to 197.07 watt by calculating. In the problem, this is the option C. So it's a linked data question, and both the options are the first part. For the first part, the correct option is option A basically. Sorry, it's not option C, it's option A. For the first part, the correct option is option A. For the second part is option C. Thank you.